In this study, we analyzed the degree of coarticulation in read and spontaneous speech across different communicative contexts. Speakers adjust their speech in response to the communicative situation, producing hyperarticulated speech to overcome a communication barrier. Previous studies using read speech have yielded mixed findings on whether hyperarticulated speaking styles lead to coarticulatory resistance. In fact, Scarborough and Zhe-chen found that spontaneous speech directed to a real listener was more hyperarticulated and showed greater vowel nasal coarticulation than read-clear speech. However, because the speaker in their studies might not necessarily experience a communication barrier, the current understanding of the relationship between coarticulation and hyperarticulated speech is still limited. We therefore examined how the degree of coarticulation is affected by speaking style adjustment when speakers are experiencing a real communication barrier, and when they are just imagining a perceptual difficulty on the part of the listener. Here are the main findings from our study. First, coarticulation is reduced when there are communication barriers, whether they are real or imagined. This reduction of coarticulation is in line with the models of targeted speaker adaptations. Also, speakers flexibly adjust their speech patterns in response to the specific communication challenges they are facing. We obtained these findings by analyzing consonant-vowel coarticulation in speech from the LUCID corpus. The speakers read sentences conversationally and clearly, as if to someone hearing impaired. They also completed an interactive test with the listener in good listening conditions, and when their voice was vocoded, or mixed with talk BABBLE, or when their partner was a non-native speaker. We quantified coarticulation using a spectral distance measure. A larger distance means less coarticulation. This figure shows the distance values by condition, and here's the key result. Speech produced when the speaker's voice was mixed with BABBLE was the least coarticulated, followed by speech when the speaker's voice was vocoded, speech to a non-native listener, and read-clear speech. Speech to a listener without a communication barrier and read conversational speech was the most coarticulated. We will continue to investigate how reduced coarticulation contributes to various perceptual processes. The findings will have implications for implementing signal processing algorithms in a more naturalistic way. This is the end of our video. Thank you for watching.